The last section of Unit 6 is about geometric sequences. Now, you may remember these because we did arithmetic sequences a couple of units back. So to review, what was an arithmetic sequence? This is an example. Arithmetic means we added on the same difference to each term. So when you looked at that, what you said was, okay, I've got a term. What did I add on to 1 to get to 4? I added on 3. Now to make sure it's an arithmetic sequence, we have to make sure that we add on 3 every single time. So in this case, we would say, yes, it's arithmetic, and the difference between each term is 3. Well, now for a geometric, it's the same thing, except it means to multiply. And we multiply by the same ratio. Because really, if you remember, ratio means to divide. So in other words, what did I divide 3 by to get to 1? Oh, I divided by 3. What did I divide 9 by to get to 3? 3. What did I divide 27 by to get to 9? 3. So you can look at this either way. Even though a ratio means to divide, most people look at it as you multiplied by a number instead of dividing by the number. Either way, it's correct, because remember, division is just rapid multiplication in the backwards direction. So one of the things we're going to have to go over is our terminology, our vocabulary. Okay, term. Do you remember what a term is? Well, let me grab this one right here. And what we're looking at is a sequence. So that's probably another word we should put in here. This is a sequence. And right now, in this sequence, it happens to be a geometric one. It happens to be infinite because it's going on forever and ever, and we are seeing 4 terms. That's the first term, that's the second term, that's the third term, and that's the fourth term. And then we don't know the rest of the terms, but we could figure them out if need be. So remember, we would write something like this. The first term is 1. The second term is 3, and so forth. The third term is 9. Remember, these are subscripts. Sub do not have any mathematical operations. They denote position. Recursive. Recursive means to look back. So for example, if I asked you, what is a sub 5, you would have to look back at a sub 4. You would have to go, well, a sub 4 is 27. And then to get to my next term, a sub 5, I take a sub 4 and multiply it by 3. So therefore, 27 times 3 is 81. So that's what recursive means. Recursive means to look back. So I'm going to hold off on explicit, and I'm going to come here, and I'm going to go over this. This caused a bit of a problem last time. It also causes a bit of a problem because the Algebra 2 kids still have a problem with this. This and this are really saying the same thing. All right. Remember, they're subs. So we're looking at position. So this is the term in the nth position. So if I looked at term a sub n plus 1, how does that relate to the nth position? This is the term, and actually I'm going to type this. All right, this is a term in the position after the nth term because they wanted you to go to the n term and then go one spot beyond it. So how is that different than a sub n and a sub n minus 1? Well, a sub n is still the term in the nth position, but guess what? That's right. A sub n minus 1 is now the term before the nth position. And it all makes sense right now. You're like, yeah, that makes sense, Mrs. Trulin. But when we go back to try and write equations, that's where it gets a little tricky. You can use either one to write the equation. Now, we didn't do much of the explicit, but the explicit we're going to talk about on the next page. All right, here we go. We have 5 examples here. And the first thing you're going to have to do is figure out, are they geometric, arithmetic, or neither? All right, so I'm going to look at this. What did I do to 4 to get to 12? Well, I could have added 8 or could have multiplied by 3. Well, now we're going to have to look to what did we do to 12 to get to 36? Well, adding 8 onto 12 would get me 20. Doesn't work. But if I multiply by 3, that works. That works. That works. So this was a big geometric. If I wanted to write this sequence using recursive notation, all right, hang on, here we go. You can use either one, a sub n plus 1, a sub n minus 1. This is what I do. To find the a sub n minus 1 term, I have to go to the term before it and multiply by 3. Or you could say to find the nth term, I go to the term before it and multiply by 3. Both of those are right if you understand that if this is the term, a sub n, then the term before it is n minus 1. And if the term is a sub n plus 1, then the term before it is a sub n. And a recursive, if you remember how I said it, is always the term equals, and again, I'm going to type this because I don't think I'm going to fit it all in. Term equals term before, and then you times it by the common ratio. And I don't care which terminology you want to use, vocabulary of a sub 1 or a sub n, and then n plus 1, or a sub n and a n minus 1, whichever one. Okay, the explicit notation is this. To find any term, we start with the first term and then multiply by the common ratio n minus 1 times. What? What is she saying? Oh my God, this is so confusing. Well, let's look at this a little closer. If I wanted to find the 1, 2, 3, the fourth term here, right? This is the fourth term. This is the first term. I could have gotten right to that fourth term very simply by taking the first term, multiplying it by 3 to the third. Why is it multiplied by 3 to the third? Well, that's how many 3's I multiplied by. Whoops, didn't mean to erase that, to get there. 1, 2, 3. Started with the first term. I multiplied it by a 3, by another 3, by another 3, and that got me to 108. So this would be to find any term. I start with the first term, which happens to be a 4, and multiply it by 3, and I do it one less than the term I'm looking for. All right, let's look at the next one. How did I get from 5 to 15? Well, I'm going to start with the geometric. All right, I'm multiplying by 3 again. So this is geometric, and everything is still the same as above. I like to say to find any term, I take the term before it and multiply by 3. Or I can do the explicit, which is to find any term. I start with the first term and multiply by the ratio n minus 1. Now you may be asking, what's the difference between the recursive and the explicit? Well, I'll sum that up right now very quickly. Let's say I asked you to find the 12th term of example 2. Oh my goodness, I would have to do it recursively. I'd have to keep multiplying and multiplying and multiplying by 3 until I got to my answer. But the explicit is very simple. To find the 12th term, whoops, and that can't be 4, obviously. That has to be 5, because I started with the 5th term. I started with the 5 in the first spot. So going back here, if I want to find the 12th term, I have to start with my first term. I'm going to keep multiplying it by 3, but I only have to multiply it by 3 11 times to get to the 12th term, right? Makes sense. 5 is the first term, plus 11 more gets me the 12th term. All right, how about my next one? What did I do to 5 to get to 15? I multiplied by 3. What did I do to 15 to get to 20? Oh, wait, I didn't multiply by 3. Oh, tricky Trulin. This is an arithmetic. I'm adding on 10 every single time. So it's a big old arithmetic. And just to review, if you were to write that in recursive notation, look how easy it is now. It makes sense. To find any term, I start with the term before it and add 10 onto it. The explicit would be to find any term. I start with the first term and I add on 10, and this time I times it by n minus 1 because I'm adding on, well, again, how many 10s? One less than the position I'm looking for, because this is the first position, and then I just have to add on how many more positions to get there, right? So say if I was going to the 20th term, this is the first term, and then I would add on 10 19 times, because 19 times plus the first time gets me 20. All right, what did I do to 36 to get to 12? I multiplied by 1/3. What did I do to 12 to get to 4? I multiplied by 1/3. What did I do to 4 to get to 4/3? I multiplied by 1/3. So this is indeed geometric. Recursive. To find any term, I look to the term before it, and I multiply by 1/3. Explicit. To find any term, I start with the first term, and I multiply by 1/3 to the n minus 1 time. All right, and this last one, you might have guessed by now. This one is a neither. Because 1 times 1 gets me 1, but 1 times 1 wouldn't get me 2, so geometric's gone, and 1 plus 0 would get me 1, but plus 0 again wouldn't work there. So we don't have to know the recursive or the explicit for this one. Okay, the last example we're going to look at says find 3 geometric means between 4 and 324. What? Okay, let's break this down. This means we have a geometric sequence. So your brain right now, geometric sequence means I'm multiplying by the same number, multiplying by r. And there are 5 terms. So I'm going to give myself a little thinking spot. All right, so my little thinking spot means this. I have 1, 2, 3, 4, 5. And if you're going, wait, how do you know I had 5? I don't get it, Mrs. Trollen. Well, look, it says there are 3 geometric means between 4 and 324. So that means 4's got to be in the beginning. 324's got to be in the end. And there are 3 spots. So if you don't like the word means, it's really fancy for the 3 terms between 4 and 324. All right, well, just common sense. We don't even have to apply any of the formulas. If you really understand geometric sequences, this is what your brain should say. I started with the number 4, and then I multiplied by an r to get to the second term, by another r to get to the third term, by yet another r to get to the fourth term, by another r, and that got me to 324. And does that make sense about this explicit right now? See why it was always n minus 1? Because even though there are 5 terms here, I multiplied by 1, 2, 3, 4 r's because 4 is the first term. So there's 1, 2, 3, 4, 5 that gets me to 324. Okay, now this is just basic math. Clean this up. R to the 4th is 324. Divide by 4. Divide by 4. And I get r to the 4th equals 81. So you've got to think, what number raised to the 4th power gets you 81? Well, to do something to the 4th power, there's a really easy shortcut. it means to undo a fourth power. We take the square root twice. So that then makes this just plain r. And then the square root of 81 is 9. And you got to take the square root one more time of 9. Oh, there's that number 3 again. Oh my gosh, I was really addicted to the number 3. Hey, but we're not done, because the problem said find these 3 little rascally terms in the middle here. All right, so that first term, the second term actually, that would go right here. It's very simple now. 4 times 3, so this is 12. And now I can find the next term, which happens to be the third term. I just take 12 and multiply it by 3, and it's 36. Then I get the fourth term, which is 36 times 3, which is 108. And then that works because 108 times 3 is 324.